Next we will learn about zero of a polynomial. The zero of a polynomial p of x is the value of x for which p of x is 0. For example, consider the polynomial p of x equal to 3x plus 5. So we need to find the value of x for which this p of x would be 0. So how would you do that? So you equate 3x plus 5 is equal to 0. You would end up with 3x equal to minus 5, x equal to minus 5 by 3. So for x equal to minus 5 by 3, p of x would be 0. So this value is called the zero of that polynomial. This is also called the root of that polynomial. So root of the polynomial or zero of polynomial. Next we will learn about another property of linear polynomials with one variable. A linear polynomial with one variable will always have one and only one zero or a root. So let's verify this. So we have learned in the previous classes that a linear polynomial with one variable is always a monomial or a binomial. So it's in the form of ax, which is monomial, or ax plus b, which is a binomial. So let's try to calculate the zeros for the first and second polynomials. So in this case, if ax is equated to 0, we know that for x equal to 0, this polynomial would be 0. So there is only one root or 0 for this polynomial. In the second case, if we equate ax plus b equal to 0, we end up with x equal to minus b by a. Again, we have only one root for this polynomial where x equal to minus b by a. So a linear polynomial with one variable will always have one and only one zero. Whereas in the case of a quadratic polynomial, that need not be the case, because a quadratic polynomial will have either 0, 1 or 2 roots. Consider the example p of x equal to 3x square. In order to calculate the zero of this polynomial, we equate 3x square equal to 0, and we know that for x equal to 0, this polynomial will become 0. So there is only one root in this case. Consider another quadratic expression, x square plus 1. Again, in order to calculate the root, you equate it to 0, whereas here you end up with x square equal to minus 1. There is no value for x which will satisfy this polynomial, because x square is always positive, so there are no roots in this case. Now let's consider the third case. Let's say q of x equal to x square minus 5x plus 6. If you equate this polynomial to 0, and by applying the roots of the quadratic equation formula to this expression, you will end up with two roots, which are 2 and 3. So for x equal to 2 or x equal to 3, this equation would become 0. So there are two roots in this case.